So next, I'm going to go over chromatography. So chromatography is used when you want to isolate specific molecules from a large mixture of other molecules. So this uses the premise that more similar compounds will stick to each other based on like polarity or charge. And since it will stick to the surroundings, it will move more slowly. Sorry, it should say not. Sorry, it should say stick to them and move more slowly. So for chromatography, the sample that you want to test will be placed on a solid medium. So the solid medium is also known as the stationary phase or the absorbent. So remember that stationary, like it doesn't move, the solid does not move. And the solid is also the absorbent because it will absorb the sample that you place on it. And then the mobile phase is the phase that moves, mobile as it moves. So the mobile phase will run through the stationary phase and displace the sample as it carries it through the solid medium. It's also known as eluting. So the mobile phase will elute or carry the sample through the solid medium. So the sample will adhere to the stationary phase with different strengths based on the polarities, the chemical and physical properties. And because it will stick to the stationary phase at different strengths and move at different speeds, you can distinguish the differences between the different compounds in that mixture. So this is known as partitioning when you have the sample on the stationary phase, and the sample will separate out into the different mixture, the different molecules in that mixture. So partitioning is like when you're separating all the different compounds in that large mixture. So like I said before, since the different compounds will have different polarities and will adhere to the stationary phase at different strengths, it will elute at different rates. And this causes them to have different partitioning coefficients. So this is when you measure how far each substance travels on the stationary phase in a given amount of time as it's being carried by the mobile phase. And this partitioning will separate the different compounds on the stationary phase, and it will isolate each substance so you can tell like which substance moves farther and which substance didn't really move at all. So there's different types of chromatography, and this is because there's different media that can be used as the stationary phase. So like I said, for the compounds will adhere to the stationary phase at different strengths, depending on like the different physical and chemical properties. So if you can use like a non-polar stationary phase, and that causes the non-polar compounds to stick to the stationary phase more, and it won't travel as far as the polar phases. And the opposite will happen if you use a polar stationary phase. If you use a polar stationary phase, the polar substances will stick to the stationary phase more and will travel as far as the non-polar compounds. So the compounds can be identified using the what is known as the retardation factor. So you'll most likely see it as capital RF. So the RF it signifies the differences between the compounds based on the distance in the spot. The distance that the spot moved and the distance the solvent moved. So when you're doing chromatography, the bottom number, the distance of the solvent move, will be the same for each compound in that chromatography sample, but the distance that the spot moved will differ based on each different compound. So once the compound separates into the different compound, once the spot with the sample that's placed moves, it will separate out to its different compounds. So some compounds will move farther, while some compounds will barely move from that original spot. And when you take that distance that the spot moved and divide it by the amount the solvent moved, you can find the RF factor, and the RF factor is used to distinguish between the different compounds. So here's a example. So the first example is that I'm going to go over is thin layer chromatography, or also paper chromatography. So those two are very similar. They just differ based on the medium that's used for the stationary phase. So thin layer chromatography, also known as PLC, uses a thin layer of either silica gel or alumina, while paper uses cellulose. So TLC, it'll have the thin layer of silica gel or alumina attached to inert carrier sheet, most likely paper, but you'll place the compounds and not on that side with the silica gel or the alumina. So like I said before, spotting, that's when you put the sample directly onto the absorbent at the bottom. And so this sample will be placed on the stationary phase. And then once the mobile phase carries the sample through the stationary phase, it'll move it to different distances on that stationary phase. So as you can see on the right, there's 3 spots at the bottom where the samples were placed, and the 3 different samples moved to different spots on the stationary phase as it's carried by the solvent. So as you can see, 1 and 2 moved more than 3 on that first chromatography plate. So this most likely shows that the first and the second are most likely different than the stationary phase that was used, because this mobile phase was able to carry it more during the experiment, while spot number 3, it moved a lot less than the first 2 spots. So this is because the compound used on spot 3, it was more similar to the stationary phase, so it adhered to the stationary phase more, and it was carried less by the mobile phase. And then, as you can see on the right, after enough time, the solvent was able to carry the other solvents further. Then so 1 and 2 traveled more than compound 3. And further on the right, you can see the RF factor calculation. So X is distance that the compound that was spotted, the distance that moved, and then Y is the solvent front. So on the top, you can see the solvent front. That's how far the solvent moved. So as the solvent's moving, it will carry the spots. And if you divide the distance that the spots moved by the distance that the solvent moved, you'll find the RF factor. And the RF factor can be used to distinguish the different compounds that were spotted. That's thin layer and paper chromatography. That's like the general general example of chromatography. There's other